Hello everyone. Today we are going to discuss about laser and its characteristics. Before going to laser, let us see what is the conventional source of light. You can see here the bulb. This we use as source of light in day-to-day applications. This source, it emits light in all directions. We can see here the beam emitted in all directions. So we call this as a divergent source. We also see different wavelengths are emitted here. So that is polychromatic. And we can see here there is no any phase relation between the waves emitted by this source, and hence we call it as an incoherent beam of light. So this is the conventional source that we use in day-to-day life where we require uniform illumination of intensity of light. For example, classroom, reading room, at our home, in hall, in kitchen, where we require uniform intensity or uniform distribution of light energy, we use it, the conventional source of light. But for some applications, we require the different source of light. So this is the question, what difference do you observe between the traditional bulb and laser, that laser has different applications or special applications in engineering? You may pause the video and write your answer. I hope you have written the answer. Traditional source, as we discussed now, it is divergent and incoherent beam, whereas laser, it gives highly directional and coherent beam of light. So what is laser? Laser is acronym for light amplification by stimulated emission of radiation. Stimulated emission is the principle used in laser that was invented by scientist Einstein in 1917. So what is stimulated emission? So you can see here there are two energy levels, E1 and E2. Atom is in excited state. Now we know when atom is in excited state, there is downward transition with emission of photon. We call spontaneous emission. But what is difference or what is speciality of stimulated emission? Here another photon of matching energy is incident. And now there is transition, we get two photons. So we can define stimulated emission as emission of photon by excited atom when it is triggered by photon of matching energy. So we can see here we get two photons. Both these photons are in the same state. Means incident and new photon, they have same energy, same frequency or same wavelength. They are in phase and they are exactly in the same direction. So here we have incident one photon and we get two photons. So that we call as a amplification. Now these two photons, they interact with two more excited atoms and again give stimulated emission with emission of four photons. These four photons again give stimulated emission and we get 8 photons and so on. So this is cumulative process. All these photons have same wavelength, same phase. They have same state of polarization, that means same phase, and they are exactly in the same direction. So this is stimulated emission and it is the principle used in laser. Now for laser, we require population inversion. So what is population inversion? You can see here this is normal equilibrium. Here number of atoms in ground state energy level is greater than excited state. But for laser we require the atom to be in excited state. So you see here number of atoms in excited state is greater than ground state. This we call population inversion. So how to obtain population inversion? We call it as pumping. Method of exciting the atoms to higher energy state is called pumping. There are different methods of exciting the atoms. We may use thermal energy, we may use electric energy, or we may use photon for excitation, and that is called optical pumping. Now, what are characteristics of laser? And due to these special characteristics, laser has applications in many fields. Laser is coherent, polarized, monochromatic, and highly directional beam of light. Now, why do we get these characteristics? As we have seen, stimulated and emitted photons are in same phase. They have same state of polarization. That means they are in same phase, and hence we call it as coherent. All the photons have same energy. That means same frequency and same wavelength. That is monochromatic. And all the photons are emitted exactly in the same direction, and that we call it is highly directional beam of light. It is so directional that its divergence is very small or negligible, almost considered as zero, and therefore it can be focused into a very small point of micrometer diameter, and therefore for the laser energy density is very high. So these are the special features of laser. Thank you very much.